Okay, this is the chapter on vectors. I'm sure you've already done vectors, so this would be sort of a review. The first thing we look at is coordinate systems. And there are several coordinate systems. The one that we will use will be in 2 dimensions, and one of them is the Cartesian system, or the rectangular coordinate system, which is simply the xy coordinate system, and the other is the polar coordinate system. In 3 dimensions, we could have what we call the spherical system or the cylindrical system. So there are 2 polar systems in 3D, but we'll stay in 1 dimension, so we'll have the polar coordinate system. Now let's have a look at these. So in the Cartesian or rectangular coordinate system, we have our x and the y directions. We also have the z direction, but we'll stay in 2 dimensions. And if we have a point here, point P, we write that as x, y, where x is, if we draw a perpendicular here, it's this distance from here, from the origin up to here, that becomes the x, and this distance, the height, becomes the y. And so this point is xy, and this is an ordered pair. The first is always the x and the second is always the y. So any point on the entire plane would be represented by an ordered pair x and y. If it's in the second quadrant, a point here, the x would become negative and the y would stay positive. So this point may be, for example, -3, 2. So it's 3 on the left side and 2 in the y direction. And a point here, well, could be -4, -2, so -4 to the left and -2 downwards. Okay, and this one would be a positive x and a negative y. So let's say 4 -2, something like that. So this is the Cartesian system, and if we want to do the polar system on the same graph, we draw a line from the origin to that point. This length is r, and the angle is theta. And this point, P, can also be written as r theta. So r becomes the distance from the origin, and theta becomes the angle with the positive x-axis. Now, we want to convert from one system into another. So if this distance is x and this distance is y, then we know from the Pythagoras theorem that x squared plus y squared equals r squared. And so if we know x and y, then r becomes the square root of x squared plus y squared. So that's how we go from knowing x and y to getting the value of r. Now, if you want to get the angle, then we look at trigonometry, and we know that y over x is tangent of this angle. It's the what we call the opposite over the adjacent, or there are different ways of calling it. This is the perpendicular over base. There's also a perpendicular over the base, and there are other ways of writing it also. So the opposite or perpendicular is the y, and the adjacent is the x, that is tangent theta, and therefore from here we get theta is tangent inverse y over x. So knowing x and y, we can get r, and knowing x and y, we can get theta. So we can use these two equations to go from xy. We can go from xy to r theta coordinates. Now, if we were given the r theta and we want to find the xy, we can do a similar thing. So we look at trigonometry and we see that y over r is sine theta. Now we know theta and r, and we're trying to find x and y, so this equation will give us y equals r sine theta. And so if we know x, r and theta, we know the value of y. Similarly, the cosine of theta is the base over hypotenuse, or adjacent over hypotenuse. That's going to be x over r, and therefore x is going to be r cos theta. So these are the four equations, and these two convert from polar to Cartesian coordinates, and these would be used to go from Cartesian to polar coordinates.